Good morning, Flint Falcons. Hope you all had a nice holiday weekend. We're going to be taking some notes today on how to solve linear systems. So a system is two equations instead of one, and we're looking for the location that these two linear equations cross over at or intersect at. So I actually set this up so you can take these notes digitally, and you can do that, or if you choose to print it off, you can print it off. If you choose to print it double-sided to the short edge. Otherwise, we're going to do this digitally. So first thing I want you to do, because you're going to keep these notes digitally too so that you don't lose them, is I want you to, once you're in classroom or beforehand, I want you to go here and go Drive, and that should open your Google Drive. So Miss Egan has like multiple Google Drives, so I need to make sure I'm signed in for my RPS account. And I want you to make a new folder. And I want you to title that Math Notes. You can even put, if you want to, 8th grade math notes, because this is going to be, housed in your drive through RPS and Create. So if you want to see that, you're going to have to just refresh your page in your drive. And we can see right there is Math Notes. Okay. So we're going to use that later after we're done using the notes. But that's why I wanted you to go ahead and make that file right now. So going back to your classroom, if you go down to distance learning, this is in light gray right now because it's just scheduled. So I think I put it on the 14th, but I'm going to change that to the 21st. It's going to release on the 19th, actually. So 21st, schedule for the 19th. So once you go in it, you're going to, when you go into that assignment, you're going to see your slide, wrapping system. So go ahead and open that. Now I actually have one open, so I'm going to open mine over here. And you should see the 3 pages. So if you want to go ahead and print, you can go ahead and print. Otherwise, we're going to do it right inside of this document. So this is just the kind of opening page. If you go to slide number 2, this is where the notes are. So how do we solve a system of linear equations? So step number 1, going back to graphing linear equations, which you guys have been reviewing the last 2 days. First thing we need to do is we need to rewrite I'm just going to keep it all capitals because I like to make my life easy. Rewrite each equation in slope intercept form. You don't remember what that is? It's y equals mx plus b. Might have to expand my box just a little bit here. And if I can actually, there we go, it did fit. We should remember that the m is the slope and the b is the intercept. So identify the m, which is the slope, and B, which is the y-intercept, and graph each equation. I'm going to just change that to 12 point to make it fit. So I need to identify the m and the b for each equation and then graph each equation. And then the third step is I need to identify the point of intersection if one exists. So if one exists, that means that there's an answer to the system. If one doesn't exist, it could mean that there's no solution or there's a solution. We're going to be going over those as well. So example 1, y equals 1/3 x minus 2, and 3y equals negative 2x plus 3. So the first equation is in slope-intercept form. So I can look and see that m equals 1/3 and b equals negative 2. Second equation I'm going to have to change. So 3y equals negative 2x plus 3. In order to convert it, I'm going to have to divide by 3. That's on both sides, or every term gets divided by 3. When I do that, I'm going to wind up with y equals negative 2/3 x plus 1. So its m and b is m equals negative 2/3 and b equals positive 1. So coming down here to the graph, I want to graph a line that has a slope of 1/3 and a b of negative 2. So I know negative 2 on the y-intercept, 1, 2, I'm going to start right there. And if I'm going to go have a slope of 1/3, that means I'm going to go up 1 over 3, up 1 over 3. So I'm going to go ahead and grab a line. So up here, I just select a line and hit a line. And I'm starting at negative 2. And I know I'm going up 1 and over 3. So I don't know if it's going to let me do that. So here, I know I went to there. Now I'm going to go into this line and extend that out. So I know down 1 over 3, down 1 over 3, basically just keeping the same thing there. And I'm also going to click on it and change that. Well, it's not going to let me change the color right now, so I'm just going to leave it as is, but I can see that the line's there. That's the first line. The second line, I'm going to start at 1, and then I go down to and over 3. So if I do that, I can see I should go through the other line right there. So I'm going to grab a line, starting at 1. If I went down 1 and over 3, My line will look like that. Nope. Just looking for the color part here. I'll have to go back and find that later. But it's right there. And if we needed a closer look, we can actually zoom in. I made this 200%, so you can see that I've made them pretty close to being at that axis point. Okay. And just going to zoom back out. Move on to number 2. So the first one, negative x plus y equals 1, is not in slope-intercept form. Take my cap off. X plus y equals 1. So in order to put it in, I'm going to have to add x to both sides. And that's going to leave me with y equals x plus 1, making my m equal to 1, because that's what the coefficient is in front of x. Remember, we don't see it, but it's there right here in front of the x. And making b equal to 1 as well. We go down and do the second line. Actually, I'm going to change that to red text for the second line. So x plus 2y equals 8. I'm going to have to subtract x from both sides, giving me 2y equals negative x plus 8. I'm going to divide everything by 2. And I get y equals negative 1/2 x plus 4, making its m equal to negative 1/2, and its b equal to 4. Now I know some of you guys are probably tempted to just wait to the end and write down these other notes. But remember, if you don't know how to do it, what are you gonna be able to refer back to later? And let's go ahead and do the work on this one as well, and then we'll go through and graph both of them. So x plus 4y equals 12. I gotta move that x, so minus x on both sides, or subtract x from both sides. I get 4y equals negative x 12. Then divide everything by 4. I'm going to get y equals negative 1/2 or negative 1/4 x plus 3. And just so we're clear, that x is actually being multiplied by the 1/4, same with over here. X is being multiplied by 1/2. It's not in the denominator. So m equals negative 1/4 and b equals 3. And I'm just changing it for the second one, so I have 7x plus 4y equals negative 12. I'm going to subtract 7x from both sides. It's going to give me 4y equals negative 7x minus 12. Divide everything by 4. And I'm going to wind up with y equal to negative 7/4 x minus 3. extend that text box just a little bit here. And I was using a 14 point. I'm going to bring this back down to 12. So I have some extra room. I'm going to bold it because I don't like that. And now I know that my M is equal to -7/4 and B is equal to -3. Let's go down and try to graph these. So I'm going to select a line. So the first one we said is 1 and 1. So if I start at 1 and I go up 1 over 1, up 1 over 1, because remember, whenever you have a whole number, you just put it over 1. That's how you'd find out what your run is. So it's literally starting here and going straight line. So straight line. Should be. Okay, line, where are you? I don't want to animate. I just want to change the color. There we go. So I'm going to keep this one a dark black. Going back over here. Keep that line color a dark black. And this one I'm going to change to red. So over here that's black, and I'll do the other one starting at 4 and then -1/2. So that means you go down 1 over 2 to the positive, down 1 over 2 to the positive, or in reverse, up a +1 and over a -2. So starting at 4, 1, 2, 3, 4. So down 1 over 2. This line, actually, we need to move it down a little bit. It's supposed to be going through 1, not 2. So if we do that, we start at 4 and we go down 1 over 2. Down 1 over 2. This line. There we go. It's the right angle. So grab another line. Start at 4, 1, 2, 3, 4. And if I go down 1 and over 2, I should see that it's going to go straight through that line. And then down 1 over another 2. Down 1 over another 2. And we're going to make that color red. Okay, so going back to this one, we didn't actually put this in there. We're going to do that now. The spot where it crossed over, no, we'll do that. We'll do this last one, and then we'll go back and do all 3 of them where they cross over. So for this one, we have -1/4 and 3. So we're going to start at 3, 1, 2, 3. And -4 means down 1 over 4, down 1 over 4. So I'm going to grab a line and start at 3, 1, 2, 3. And if I went down 1 and over 4, see, over 1, 2, 3, 4, be right here. And down another 1 and over 4, it's going to be off the graph. Again, come on, line, we're starting at 4. opposite way. Grab it. Sure that line color. So now we start black. Second one, we started at -3, and we're going to go down 7 and over 4, which will probably take us off the graph. So we're going to have to go the opposite way. So if we started at -3, which is right here, and we want to go up 7 and over 4, so we can also kind of reverse that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Sure, we can kind of match up here. So we're at -3, so 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 3, so that gives us 7. Going back to here, we were at 3, so we do need to move this down 1. And we're going to see that these will cross over right there at that point. Just extending that line so it covers the whole graph. Okay, and we're going to give it a color of red. If I want to make the line thicker, I can make it thicker, I can make all of them thicker, so maybe it makes it a little bit easier to see. So now we've graphed all of our equations. They've all had, they all have their own line. So there's 2 lines on each graph at this point, and we should be able to tell where they're crossing over at by finding that location on the coordinate grid plane. So I'm going to zoom it in a little bit. So we can see on this graph over here that this is 0, 0, so 1, 2, 3, and down 1. So the place where it crosses over is 3, -1. On the second one here, put our answer right next to it here. Going from 0, 0, we go over 1, 2, over 2, and up 1, 2, 3. So our answer is 2, 3. And in our last one, our answer is over 1, 2, 3, 4. So we're over 4 to the left. That's going to give us a -4. And we were up 1, 2, 3, 4. So what does this mean, besides the fact that this is where these 2 equations cross over at? Well, what this tells us is that this location is shared between these 2 lines. The other thing is, if we're dealing with the equation, if we take this answer and substitute it into the equation, doesn't matter which one, in fact, we should substitute in both of them, that we would create a true statement. So if we took this where x is 3 and y is -1, so 1/3 times 3 would give us 1. And 1 minus 2 would give us -1. So that creates a true statement when substituted into that equation. The one down here, so -2 times 3 would give us -6, and -6 plus 3 would give us -3. And 3 times -1 would give us -3. So I know that I did this correctly because when I take this point and substitute it back into the equations, I create true statements in both of the equations. And the same thing would happen here if you use these answers. So -2 plus 3 equals 1. Put the 2 in for the x, becomes -2. Put the 3 in for the y, becomes 3. And it sure does equal 1. So 2 in for the x would be 2. 3 in for the y would be 2 times 3. So 2 plus 6 would equal 8. true statement. That's how you can tell or check your work to make sure that you've done it correctly. And that's how we graph linear equations. And why would we want to use this? Well, if you're a business right now and you need to know what is your profit versus your expenses to run your business, where they cross over, that's your break-even point, or that's where your profits exactly equal your expenses. So lots of businesses are using that right now to determine, should they be open or should they not be open? If we go to the next slide, there's also two situations that could occur. I'm going to zoom this back out. Besides coming up with a solution, because of course in math, everything doesn't have a solution. So we have a situation where it's no solution, and we have a situation where it's going to be infinite number of solutions. So we have to follow the same rules. We've got to put both of these in slope-intercept form. So where it says work, I'm going to go ahead and go into that text box. The first one is set up for us. So m is equal to -3, and y-intercept is equal to 2. Second one, 3x plus 4y, or plus y, equals -4. Change this to red, so changing it to red, people. We'll change it at the end. And if I want to move it, I'm going to have to minus 3x from both sides. And I'll end up with y equals -3x and -4, making my m equal to -3 and my b equal to -4. We're going to go over here and do the work over here as well, so then we can discuss kind of what we see in the equations. How can we tell if something is going to wind up being no solution or infinite solutions if we don't graph it? So -x plus 2y equals -2. I'm going to add x to both sides. Remember, to put in slope-intercept form, we want to isolate that y. Y has to be all by itself. So 2y equals x minus 2. And last thing we have to do is we have to get rid of that 2 in front of the y, because it can only have a coefficient of 1. So we're going to divide by 2 in both sections, or everything. Y equals 1/2 x minus 1. I'm going to come up here and change it to red. So I have 4y equals 2x minus 4. Doing the second equation, I'm going to have to just go down because it didn't have enough room there. So I'm going to have to divide everything by 4 to get y isolated by itself. I'm going to use my arrow key to move down and spacer to move over. So I'm going to end up with y equals 1/2 x minus 1. So it's m and b here. M equals 1/2 and b equals -1. For this one, we had m equals 1/2 and b equals -1. So what we should notice in both of these scenarios is that your slopes are the same. So -3 and -3, 1/2 and 1/2. So if you're going to be a special solution, your slopes are going to match between the two equations. Then the difference between infinite solution and no solution is your y-intercept. Because here the y-intercept is 2, and here it's -4. So this example would be like this person is given a 2-meter head start from the starting line, and this person starts 4 meters behind the starting line, but yet they're moving at the same pace. So when that occurs, one is never going to pass the other in the race, right? They're never going to cross over. While as here, they both start 1 meter behind the starting line, and then they move at exactly the same pace. So if I was watching the race from the side, their bodies would actually line up. So let's go ahead and graph these. What are they going to look like? Well, 2 and -3, I'm going to grab a line here. I'm starting at +2, 1, 2. And since my slope is -3, that means I'm going to go down 3 and over a +1. So down 3 and over a +1, down 3 and over a +1, right? So starting at 2, down 3 over a +1, down 3 over a +1. That's what my line's going to look like. So opposite up 3 and over a -1. And I'm going to give that line black color, make it a little thicker. Second one, starting at -4. So 1, 2, 3, 4. And if I went down 3 and over 1, of course, I'd be off. So I'd have to do the opposite. And that's going to be go up 3 and over a -1. Up 3 over a -1. Up 3 and over a -1. And I can see that these two lines don't intersect. And they're never going to intersect because they are parallel lines. On the other side, they both have the exact same information. So when you take that into account, we should only have one line. The lines would be sitting on top of each other. So if I grab a line and I start at -1 and I go up 1 and over 2, as my slope asked me to do, up 1 over 2, up 1 over 2, up 1 over 2. So if I over here, I'd go, once you grab that thing, go down 1 and over 2, down 1 and over 2, down 1 and over 2. So if I put the other line on top of it, right, I grab another line, I did it in the exact same spot, I would only see one line because they'd be lying on top of each other. So in this instance, they don't cross. So my answer becomes no solution. And I can put a 0 with a line through it. Not going to let me do it on here. Over here, my answer is infinite or all solutions. And what does this mean? This means over here that it doesn't matter which point I put into these two equations, they will never create a true statement in both of them. So if I put 0, 0, or I take this point, any point on this line, if I put it in for the first equation, it would make a true statement, but in the second one, it would make a false statement. But I take any point from this line and put it into the equations, it will make a true statement for the second one, but not the first one. And I'm looking for a coordinate point, the same coordinate point that I can put into both of them to make both create a true statement. Over here, infinite or all solutions tells me it doesn't matter. Whatever point I want to put in along here, I can put it into both equations and they'll both be true. So here we have many, many solutions. Here we have no solutions. And on the previous page, we had one solution, which is the most common, obviously, when you're doing equation or doing systems of equations. Okay, so before you turn this into me, the last thing I want you to do is I want you to go File, and I want you to make a copy of the entire presentation. And you can, Mine, I'm going to name mine the key, but you could perhaps put your name on it. Come down here. I'm already in the systems folder, but say you weren't, say you were just like in your drive, you would go through your drive, and I found 8th grade math notes, and I hit the arrow, and then I'm going to hit select, and it will take a copy that I just made, excuse me, and put it into my math notes file. It's also going to open an extra one on here for you. That's your copy. You want to go back to your original and turn it into me in Classroom with the turn in button key. And that's it. Those are the notes for graphing linear equations. If you have any questions, please put them in the comments or send me an email. I hope you guys are all doing fabulous, and maybe we'll do a Zoom call real soon.